Okay, mathematical modeling. This is what makes math so powerful. It's the ability to get real data, real world data, and fit it, find an equation that kind of models it, represents it, and then use that equation to make future predictions. Right, so data in this particular example is data on credit card debt in the US, and we have data from 1992 through 2011. One thing that's really important to notice is that when we are using years as one of our coordinates, usually it's almost always the x coordinate, we don't use the actual year. Whatever that starting year is, we're going to make that year 0. That's going to be our reference, and then we're going to go from there. So it's going to be years since whatever. In this case, years since 1992. So instead of using a 1996, we're going to use a 4. Instead of 2000, use 8 because it's 8 years since 1992. Okay, and when it comes here to finding the debt in 2014, we're not going to put 2014 into our equation. We're going to have to figure out how many years that is since that 1992. Okay, first thing we want to usually do when we are given some data is make what we call a scatter plot. We want to see what does it kind of look like if we were to map out those points. And so I've got my years labeled down here again. It's starting with 0, 2, 4, 6. And then my debt, I went up in increments of 2,000 so I could get it all in there. 0, 3,800 would be about here, 4, 6912 about there, 8, 8308 there, and so on. And you can see it does kind of look like a line. Okay, it's kind of nice to see. Your calculator can do this for you as well. If you go to this button, I'll turn it on, and you go to this button called Stat, okay, that was a picture of what it's going to look like, but if I go to this button called Stat, and I go to Edit, I've already got my data in there. Maybe you have data in there, but it's not the right data. Go up to whatever the list heading is that you want to clear and hit clear and enter, and it cleans out that entire column. Okay, now I need to put my numbers back in. So 0, and then 4, and then 8, and then 12, and then 16, and 19. Then you would go through and you put in your list too. If you need to pause a moment to do that, go ahead. You do want to be very sure that whatever data you put in here is accurate, because one slight typo is going to mess up your whole problem. Okay, now before I can actually see the scatter plot, we're going to get out of there and we're going to go to the y equals button. Now if you don't already have it on, which you probably don't, you need to go up to the plot one and hit enter to highlight that. So you want to hit enter, and that highlights it, that turns on our plots. Okay, now if I were looking at a standard window and I just hit graph, I wouldn't see anything. To make sure that I'm going to see the right window, we're going to go down to on zoom to number 9. And that says zoom into the stats, zoom into those things we just put in those lists. So I hit enter, and then it automatically changes my window for me. So there's our scatter plot. Okay, now let's see if we can actually do what they're asking us to do, which is to find a function to model this, find an equation of a line. So we're going to have to grab a couple data points and get the equation, and then we're going to estimate what it was in 2014, right? Okay, so here we go. We're going to choose any two data points so that we're all on the same page. Let's use 4, 69, 12 and the 16, 10, 69, 691. Find the slope first, difference in my y's over difference of my x's. Be sure you go the same direction for both x and y. And that simplifies to about 314.9. Now we're rounding, that's going to throw off our answers, but we'll just have to live with it. It's a model, it's not perfect. Then I'm going to use my point slope equation. I use the smaller numbers, it doesn't matter, we come up with the same if you use the 16, 10, 691 number, or ordered pair. So y minus the 6912 equals my slope, 314.9, times x minus 4. Distribute, and then add our 6912, and we come up with y equals 314.9x plus 5652.4. Okay, now what does this mean? X is the number of years since 1992, and when I plug in that value, I will come up with the amount of credit card debt per household. Okay, so to answer the last part of the question, if I can scroll it down, there we go, we want to estimate the number of credit card debt in 2014. Okay, 2014, I can't use that number. I have to find out how many years is that since 1992, so I subtract 1992 and come up with 22. That's the x I need to use in this equation that we just found. So I plug 22 in for this x, down here we've done that, and I come up with approximately $12,580. It's a lot of debt. It's not a good sign. Hopefully you're not in that situation. If you are, See if you can get yourself out.